Hi, I'm Michael Pfeiffer from Industrial Metallurgists. This video is a companion to our phase diagram article that's on our website. You can go to our website and read the article in addition to watching this video. Um, this discussion is about phase diagrams. Phase diagrams are a tool that's used to understand the phases present in an alloy after a heat treating. A phase refers to a physically homogeneous state of matter. In metals, a phase is a combination of the elements present in a metal. It could be an alloying and elements in the main metal, or it could just be the main element in the metal. And a phase is distinguished by its composition, by the type of atomic bonding, and the arrangement of the atoms within the phase. Within an alloy, two or more phases can be present at the same time. Within a pure metal or a metal that just has impurities, then there will only be one phase present, typically one phase present at one time. So this shows two different metals with the phases present in them. The metal on the left is an aluminum copper alloy. What we see that the light colored phase is grains of aluminum, and the dark colored particles are an aluminum copper precipitate, and that's a different phase. So there are two phases in that alloy. And in the alloy on the right, we see a carbon steel that consists of ferrite, which is the light colored phase, and cementite, which is the dark colored phase. And both phases are combinations of iron and carbon that are present in the steel. The thing that's important to recognize about phases is that different phases have different properties. And when more than one phase is present in an alloy at one time, then the alloy is essentially a composite material whose properties are based upon the properties of the individual phases in the material. So the phases that are present in an alloy depend on the alloy's composition and also the thermal treatment to which the metal was exposed. And we use phase diagrams to understand this relationship between the alloy composition and the phases present in order to understand the effects of heat treatment, in order to predict the heat treatment, as well as to understand what's happened to a metal after heat treatment if there's something wrong with the metal. So commonly used phase diagrams are the iron carbon phase diagram. It shows the temperature versus percent carbon on the x-axis, and we see there's different fields here that indicate the phases that are present for different amounts of carbon and different amounts at different temperatures. And then there's also, this is another example I have, is the aluminum copper phase diagram that shows the temperature versus the weight percent copper that's been added to aluminum. We're typically concerned with just the left-hand corner of the phase diagram for aluminum copper alloys. It's important to recognize or to understand that phase diagrams indicate the phases that are present under equilibrium conditions. This means that the alloy has been heated and cooled slowly enough so that the equilibrium phases form. If we heat and cool the alloys fast, then we can form other phases, and those aren't shown in the phase diagram. The other thing that's not shown in the phase diagram is the effects of heating and cooling rate on the size and the shape and the location of phases that form in a metal. And we can use use cooling rate or heating rate to influence the size and shape and location of the phases in order to influence the properties of a metal. And this is done especially with steels, or most commonly with steels, in order to get steels that have different properties, especially mechanical properties. If you're interested in learning more, I recommend looking at our courses. We have courses on steel metallurgy that discusses the iron carbon phase diagram. The course on precipitation strengthening discusses the aluminum copper phase diagram. And then there's other information on our website about phase diagrams and about the phases that form in metals and things that we can do to control the phases present in metals in order to control the properties of metals, which is very important in order to be able to develop components and design and develop products that can meet performance and reliability requirements at low cost. That's it. Thanks for watching, and good luck with your metals. Bye.